Hi, Sophia. We're going to do number 94, which is a bit unusual, but we're going to approach it with the same method we've been doing. We're going to put the two trig functions on opposite sides so we can square both sides and then do a trig substitution. So keep sine theta on the left. Let's put that root 2 on the left also. So it's plus root 2 equals cosine theta. So we just added root 2 to each side, and we added cosine theta to each side. We get sine theta plus 2 equals cosine theta. Now we're going to square both. So these are the same steps we've been using all along. We separate the trig functions onto the left-hand side and right-hand side, and then we square both sides. So this one will be sine squared theta plus 2 root 2 sine theta plus 2. Root 2 times root 2 is 2. Equals cosine squared theta. We're just going to go ahead and substitute right away. 1 minus sine squared theta. Now, there was that one case where the sine squareds were the same on both left and right, and we could cancel them out. But usually that's not true. We collect all the terms on the left-hand side, set it equal to 0. So we add sine squared theta to each side. We get 2 sine squared theta plus 2 root 2 sine theta. So we subtract 1 from each side, and we have plus 1, and equals 0. Now, this one is a little bit unusual to factor. We would factor this, and we will factor it, but note that this square root of 2 is part of the coefficient in the middle. That means that you're not going to end up with integer coefficients of the two factors that you have. When you have a quadratic in the form of ax squared plus bx plus c and all the coefficients are integers, then you can usually factor that into, often factor that into factors that have integer coefficients. But this one has a root 2. So we have to do something unusual here. Look at this 2 out in front. This 2 out in front is actually root 2 squared. So this first term is square root of 2 sine theta squared plus 2 root 2 sine theta plus 1 equals 0. And that is actually a perfect square trinomial, even though there's radicals in the coefficients. They aren't just integers, but nevertheless, we have this term squared plus 2 of this term plus 1. That is, in fact, root 2 sine theta plus 1 squared. That's a kind of difficult step, and it's an unusual way to factor, but that is, in fact, the way you could factor sine squared theta plus 2 root 2 sine theta. 2 sine squared theta plus 2 root 2 sine theta plus 1 equals 0. We can recognize that leading term, 2 sine squared theta, is in fact a perfect square. It's a perfect square of square root of 2 sine theta. And so we have a perfect square trinomial. So hopefully that makes sense to you. It is an unusual one, but we're going to now proceed with that factoring to find out our roots. All right, so our roots are going to come by saying square root of 2 sine theta plus 1 equals 0. Subtract 1 from each side, divide each side by square root of 2. We get sine theta equals negative 1 over root 2. That equals negative root 2 over 2. And of course, sine theta in the first quadrant equals root 2 over 2 at the angle pi over 4. So that's our reference angle. We're talking about pi over 4 down from pi, and pi over 4 this way from 2 pi. Those are where sine theta is negative, so that would be 5 pi over 4 and 7 pi over 4. Now we're going to check those to see which one might be an extraneous solution that comes from squaring things to find our solutions. So let's take a look at 5 pi over 4. Sine of 5 pi over 4 is negative root 2 over 2. Then minus the sine of 5 pi over, the cosine of 5 pi over 4 is also negative root 2 over 2. And so that's negative root 2 over 2 plus root 2 over 2. That equals 0. So that doesn't work. Let's check the other one. And again, we're just talking about different versions of our reference angle, pi over 4. So the values of the sine and cosine are going to be the same. All we're going to have to adjust is the plus or minus sign. So 7 pi over 4, sine is negative, but cosine is positive. So we have negative root 2 minus root 2 over 2. That equals 2, negative 2 root 2 over 2. And that equals negative root 2. And that is what we're looking for. So I did this kind of quickly. Feel free to watch it again to understand all the parts of it. The procedure we've always followed is you separate the trig functions onto both sides of the equation so you can square both sides. And then collect all the terms on the left equal to 0, except for the unusual case that the squared terms all cancel out. But collect all the terms on the left and then try to factor it. This one was unusual because there was a square root as part of the coefficient of the middle term. So we ended up with a square root as one of the coefficients in the perfect square. Okay, but once we have this, we can set square root of 2 sine theta plus 1 equals 0 and proceed to find out our two potential roots, but then check them out and find out that this, in fact, is the only one. All right, so I'm going to stop this and get this over to you. See you later.